Buddy, welcome back to Young Engineers of Today. I hope you've had a good week so far. I hope you enjoyed your class on Monday, and I hope you're ready to continue with more Raspberry Pi programming with the SenseHat. Nice little point. There is a SenseHat emulator. So just in case you don't have your Raspberry Pi your Raspberry Pi or your SenseHat handy or anything like that, you can run the emulator, and you can at least see the results of what we're doing in the code. I'm going to use it because it's going to be difficult for you guys to be able to see see a result if I code it to my physical SenseHat. So that's my reasoning. I'll do it here so that you guys can see the result put out onto the simulated Raspberry Pi and the simulated SenseHat, and get some idea of what exactly is going on with that. So, I believe you guys left off right around this slide last week, or excuse me, last session on Monday, where you printed out OMG onto your SenseHat using red, blue, and green, and then you saw like the color flipping feature, which showed off the fact that you could have a background color as well as a foreground color. So we're gonna step it up a notch here. We're still gonna do red, blue, and green, and black against a colored background letters. However, we're going to randomize those values. And I'm going to sneeze. That's what that pause was, by the way. I already did sneeze. So we're going to randomize those values of red, green, and blue specifically. Red, blue, and green. It's, well, this is similar to the last one. This is very similar to the last one. It's just we're throwing an extra wrinkle into things. But yeah, so what I'm going to do here is I'm going to show off what exactly the point of this is. So let's go ahead, and we've got our SenseHat. We're actually going to import a couple more things. We're going to import sleep from time. That almost sounds philosophical or something. And we're going to import random from random. So we've got SenseHat from SenseHat, sleep from time, and random from random. Time just counts time. Sleep makes the SenseHat wait a certain amount of time. Rand_int, as we all know, is a random integer from random, which is the pseudo-random number generator. So that's all pretty straightforward. We're just importing a few libraries so that we can expand the capabilities of our SenseHat, and then we're going to do the fun stuff with our SenseHat. So we're going to say r equals rand_int 0 to 255, and I'm just typing this out. You can type it at your own pace. I'm going to sit here and sort of walk through a block of code at a time. So if you need some time to type it, don't sweat it. Sense dot what is it? Show letter, and this is going to be O, and we're going to give it R 0 and 0, and then we're going to sleep for 1. So okay, so what exactly did I do here? Well, I created a variable called R, filled it with a random value from 0 to 255. Pretty straightforward, right? And then I'm telling it to show a letter again, in this case O, and then we've got R, 0, 0. Does anybody know what these three values are? Or at least take a guess. Yeah, exactly. They're RGB values, red, green, and blue. They're based on the idea, well, actually the phenomenon, the known thing, that if you combine red, green, and blue light in various amounts, you can get whatever color you need. So that's the idea behind RGB coloration in computers. Because what are pixels? But a bunch of tiny lights. In fact, if you get up close enough, which is really difficult to do nowadays, but certainly was possible when I was younger, because, well, I had to, make excuses, but the pixels were actually bigger. But you can still see it if you, look really close at your monitor. I don't recommend it. It's not good for your eyes. You can see little red, green, and blue sets of squares. And then there's usually a little white one as well for like brightness. But what these do is these light up in various amounts in order to create all of the colors on your screen. They're literally tiny lights. So they follow the RGB color protocol in order to generate whatever colors you need. So you can get crazy magenta colors like that. You can get the green over here. You can get the little sort of dark gray. You can get the little white of the Raspberry Pi. You can get the blue of this bar over here, the yellow of the key, the red of the O. All of these things are done using different RGB colors. Now, because it's a set of red, green, and blue lights, RGB values are red, green, and blue respectively. So this is going to be the amount of red, this is going to be the amount of green, and this is going to be the amount of blue in a range from 0 to 255. 255 is the maximum value you can give to any of these. If you feed all three of these 255, so 255, 255, 255, then you're going to get a white color, just like the background here. It's going to be just a bright white. If everything's 0, then you're going to get a dark black. Dark black, it's a bit of a... Anyway, like the cursor or the top of this tab here. That's going to be the absence of any color. And then any combination in between, like if we just color picker, if we wanted to, we can see that this sort of gives us an idea of how these things can combine in order to give us, these three numbers can combine in order to give us just a whole huge range of different colors. Like that wonderful pink, or magenta. So yeah, all this is doing is it's giving us, so green and blue are going to be 0, which means that this is going to be just red. It's going to be red from, since we're running from 0 to 255, it could potentially be, 0, and we could have nothing there. Or it could be 255, and it could be just this bright in-your-face red. Or it could be, 126, and it's kind of like a deep red. Or it could be 35, and it's this almost black. You get the idea. It's some random value, so it's going to be some shade of red between black and bright, bright, bright red. We'll do the same thing for the M, but with blue. Yeah, actually, if you just Google RGB Color Picker, Google gives you one right there. There are also HTML color pickers. If you search for a color like cyan RGB, and go to like colorhex.com, you can see that it'll give you the RGB values of whatever color. So like, let's say burnt umber. Okay, it didn't actually know that one. So yeah, here we go. So you can downtown, and you can see there's a whole bunch of different values, and you can get the color hex values of these as well. Part of the thing is, with RGB, there are so many colors that are possible with RGB. I think 256 256 times 256 times 256, which is, hold on. I can't math that in my head right now. Who am I kidding? I can't math that in my head ever. 256 times 256 times 256. It's 16,777,216 colors. In fact, that's, I believe, touching the limit on what the human eye can actually distinguish. Regardless, it's way more colors than we have names for. Way more colors than we have names for. So, not everything's going to have a name. Some of them are just going to have hex names, like good old FF6F69. Wonderful color. Very, very relaxing. Reminds me of sorbet. Anyway, yeah. So that's a possibility as well. Now for the M, we're going to do the same thing but with B. So we're going to set it to randint from 0 to 255. And if you're, a more intelligent person than me, you could always totally copy paste this from above and then change the appropriate values. But I'm not going to, just because it's nice to walk through the process again sometimes so that you can get more comfortable with it. So sent show letter M, and we're going to feed it 0 for red this time, 0 for green because it's going to be a blue value. That's why I gave it the B variable, because we want to know that it's a various blue color. So yeah, 00B, because it's red, green, and blue. Why we do a red letter, then a blue letter, then a green letter, instead of a red letter, then a green letter, then a blue letter, in order to keep everything nice and consistent, I don't know. But hey, it throws everybody for a loop, so why not? Let's do it. And then we're going to sleep for 1 second. 1 second, not 10 seconds. I'm used to also sleep commands being in milliseconds. So I was about to start typing a bunch of zeros. Then we've got G, because this is going to be our green color. Randint 0, 255, sense.show letter. G 0, G 0. Sleep for 1. So now we've got our O, our M, and our G. Now, if you'll remember back to our previous code, they place the exclamation mark as a black exclamation mark on a white background. We're going to do something a little bit different here. We're going to leverage the fact that we stuffed all these random integers into different variables. What we're going to do is we're going to show letter, exclamation mark, and we're going to do what we did before, which is set it to 0, 0, 0. However, the background is going to be whatever combination of our random colors we get every time we run the sense hat. Then it's going to sleep for 1 second, just like before, and then it's going to sense.clear, which is going to clear off the sense hat so we don't have an exclamation mark sitting there every time. So that's what our sense hat is going to do. It's going to do a random color, red color O, it's going to do a random blue color M, a random green color G, and a black exclamation mark on a random background color. So let's run it just to see what it looks like. O, M, O. Now the G didn't, the G didn't appear, but you'll notice that the background on that was purple. Purple in RGB is a combination of red and blue. In fact, purple and everything pretty much is a combination of red and blue. So the fact that we got a purple background on our exclamation mark, we know that our G actually probably worked. It's just our random value was close to 0, so we couldn't actually see the green on either the letter or the background for the exclamation mark. And we can verify this by running it again and hoping that the RNG is in our favor. Wow, all of those were zeros. All right, O, M, G, exclamation mark with a white background. I don't know why I have such a hard time saying exclamation mark right now, but I do. Part of it has to do with the fact that I think my allergies are kicking up. Anyway, so there you go. OMG, exclamation mark. Bam. It's a pretty simple code when you get down to it. It's just doing the same thing basically 4 times, essentially, just displaying a letter to the screen. And it's asking for a random number 3 times. Yes. Oh my gosh. Indeed. Block letter meme gosh. In fact, we can just run it a few times just to see what happens. As you can see, there's sort of a limited amount of colors expressed in this. Oh, that was a lot of red. The M and G didn't really show up. There are a limited amount of colors expressed. Like the ramp from 0 to 255 is pretty it's pretty small, at least in the emulated sense hat. So if you're seeing all 3 letters, chances are you're going to have a white background. If you're not, then you're going to have some color like this yellow one. But anyway, pretty simple, pretty straightforward, right? Does anybody have any questions about this one? Or anything they'd like me to go over again or anything like that? Raise your hand if you're feeling pretty confident with what we've got. Oh, wait. For the color of the exclamation point, I put BGR so it isn't just black. Ah! Oh yeah, for sure, Liam. No worries. That's interesting. All right, so I like that. So Jean-Marc flipped the RGB values so that the exclamation mark would be a complementary color, presumably. Ugh. Okay, no. Well, it doesn't really work if green isn't. If green is the one that's left out. But yeah, if red and blue are the ones, like, let's actually do this. Let's do GBR. That way we're guaranteed to get, well, not guaranteed, but we have a much higher chance of getting 2 separate colors. GRB. No. BRG. BRG. That exclamation mark was a little difficult to see. Well, regardless, this one should be good. Bam. That exclamation mark pops. I'm sorry I said that. I'll never say it again. But yeah, so yeah, raise your hand if you're feeling pretty good with this. All right. Yeah, no worries, Liam. Just go ahead and raise your hand when you're done. I ain't rushing you. I'm actually going to change these back to 0, 0, 0 for the sake of consistency. It's really bugging me that my left arrow key isn't working. Because you know what you do a lot when you're typing code? What? Oh, it's a miracle. My left arrow key. If I hit it hard enough, it works. I'm sure you can probably hear that. I can correct minor errors after the fact. Good Lord, why is that so hard? Oh. Oh. Y'all are witnessing history right now. My left arrow key is back from the dead. Today is a good day. Officially. Now, if my allergies could go away, then it'd be a great day. Or I guess, rather, if my sinuses could cooperate. Sorry, I realize I'm actually just enjoying the fact that that arrow key works again. How's everybody doing? How's your code looking? Raise your hand if you're feeling confident. Does anybody have any questions about anything? I don't see every hand up. You modeled it on a real Python? I don't want to ask how you did that. Oh, on a real Pi. Yeah. All right. Well, let's do it. Let's move on to the next thing. We're doing it. So now we're going to talk about displaying images, which the Sense Hat can also do. In fact, the Sense Hat, I mean, part of the whole thing is going to be at some point. I think there's going to be a game running on it. Don't quote me on that though. But part of the idea of running games is the ability to draw images. Well, that's built natively or by default, or however you want to put it, into the Sense Hat with the set pixel method. The set pixel method allows us to pick a particular LED, RGB LED, on the Sense Hat and change its color like magic. So let's do that. So I'm gonna clear out all this code. Bubble hat. I'll have to check that out at the end. So what we're going to do, it's just this little display here, is we're gonna make these 2 pixels light up the particular color we want them to. So it's important to note that RGB LEDs, they're modeled on an XY axis. As you can see here, this is the X axis. As you can see here, this is the Y axis. Now, here's the rub. This makes perfect sense, right? X increases as the arrow goes this way, just like how you're used to counting and stuff, like working with graph paper and things. Y, on the other hand, increases as it goes down from the top to the bottom. What? There's actually a reason behind that, and that's because terminals, old computer terminals and stuff like that, were just able to display text. And if you're a English-speaking human, I have to make sure that I properly distinguish. If you're an English-speaking human, you read from right to left, or excuse me, from left to right. Jeez. And then from top to bottom. Look at that writing. Wonderful penmanship. So from left to right and then from top to bottom. I mean, you guys have read books before. That's no surprise to you. So computer terminals were meant to emulate the same thing. Rather than having to do all kinds of math and figure out how big the screen is vertically and then start there and then work your way down to 0 and then move everything up and change, that's too much work. It was much easier just to start at 0 and increase the number as you went down. Automatically scroll the screen as the number increased, but like keep the same screen Y coordinate so that you kept writing at the bottom. Excuse me. So much easier to do it that way. So for that reason, Y increases as you go downwards. So without further ado, well, let's take a look at this. So as you can see, the blue pixel is at 0, 2, because we always announce the X coordinate first, and the red pixel is at 7, 4. So we're actually going to do some code that emulates that for us. So it's going to be sense.setPixel. singular pixel. There's one called set pixels, which is plural, which we're going to cover in a minute, but pixel is a singular one, and that's what we're going to work with. So set pixel, aha, it works. 0, 2, and then 0, 0, 255. And then sense.set pixel 7, 4, 0, 0, oh, whoops, 255, 0, 0. So what exactly did I do here? Well, sense.set pixel takes 3 parameters. It takes an RGB value, which we should all be pretty familiar with by now. So in this case, this one is going to be a blue pixel. And then it takes a set of coordinates, an X and then a Y coordinate. So just like we've got over here, it's at 0, 2. We're telling it to place itself at 0, 2. Just like down here, here's our RGB value, so it's going to be a bright, bright red. And we're going to place it at 7, 4. So yeah, let's hit play. Hey, look at that. Just like we anticipated. Just like the scriptures foretold. There's our blue pixel and our red pixel. Pretty neato, right? So, let's see. Let's expand upon that. I'm going to sense.clear in order to clear off my sense hat, because it will keep its previous things until you call sense.clear. Yes. Yes, I agree, Liam. 100%. I have disagreements with the people I work with over that. They feel like Emacs is superior, and it's just, I can't imagine living like that. Being able to split the screen is amazing, and the search and replace, and the fact that you can use regular expressions, and it's just wonderful. I am a big fan. But anyway, enough about that. So we're going to nice. We're going to draw ourselves a picture. I could type this all out, or I could just be lazy and copy paste it, and that's exactly what I'm going to do. There you go. Enjoy it. By the way, if you're using Vim and Putty, are you using Putty, Liam? Oh, okay. Dang. Because I was going to say, it'd be super easy to just, right-click in order to paste. Oh, it is? Ah. That's lame. Oh, you said that refuses to clear. Interesting. Well, hey, there you go. Well, at the very least, Jean-Marc, you'll be able to write this without having to clear the sense hat, and then maybe you can just try clearing it after, and it'll work. Hopefully, maybe. Sometimes I I tend to also do a lot of times I'm doing like just line by line stuff. So I keep it in insert mode and I use the arrow keys. I know, judge me, boo hiss. But a lot of times I'm just typing. But yeah, HJKL if I'm not running through insert mode or something like that. Or I just slash type the word that I want to get to and then jump straight to the part in the document I want to work on. So let's go ahead and run this and see what happens. We get a smiley face. Look at it, smiling. Look at it smile. That's the Joker. I don't know why it's so red. It's kind of unsettling. And come on, let's get control back. Sometimes my my SenseHat emulator does not relinquish rotation control back to me, which is unideal. But that's okay. At least it's stuck in a spot where we can still see what it looks like. But yeah, so we'll run another sense.clear. Boom, clear it off. Now, all of that stuff that we typed, I typed, copy pasted. Let's be honest here, copy pasted it. That would have been annoying to type out manually though. And if we were not blessed with this wonderful slide that had all this stuff to copy paste, then it would have involved typing out the first line, copying it, pasting 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 it, and then changing all the values in here manually, which would have been really annoying, like super annoying, remarkably annoying. So there's a better way to do it. Sort of, kind of. I say there is a better way to do it. It's debatable because it still requires a fair amount of work, but it goes a little something like this. Sense.setPixels, plural. What sense.setPixels does, and here I am just suddenly overemphasizing all of my S's. You're now all aware of sibilance. What setPixels does is it allows us to set the pixel value, or excuse me, the RGB value of every single LED that exists on the SenseHat front, which is pretty neato because it allows us to draw screens. It allows us to make pictures and stuff like that much more easily than individual calls to setPixel. However, setPixels is also unideal because setPixels takes an array. You clear it with, I'll just sense.clear, boom. I'll just send that to everybody so that everybody has that. Everybody. Sense.pixels takes an array. It takes an array of RGB values, as you can see, 25500, 25500, 25500, 25500. These are all red pixels. Oh, excellent. Glad to hear it, Liam. So these are all red pixels. And what this is doing is it's saying, make a red pixel right there. This next one is a red pixel right there. This next one is a red pixel right there. This next one is a red pixel right there. You get the idea. It's running from left to right, top to bottom. So that's annoying because that means that that array is the size of this entire screen. That is to say, 8 times 8. It's an array of 64 RGB values. And if each one of those takes 3 numbers, 64 times 3 is 192. So that means we're typing at 192 numbers. And 128 sets of parentheses. and 192 commas, because there's the comma in between each one. And that's just a lot of typing. And it starts to get really annoying to keep track of, because are you on pixel 73 or 74? Maybe you're on 75. Even though that's not possible. That's when you realize your brain is really fried, because it only goes up to 64. But regardless, it's a lot of typing. It's a lot of work. There are better ways to do it. So what we're going to do is we're going to create a color palette, and we're going to stuff those color values into variables. So we've got, I want to get rid of this. Get out of here. Move you up. There, that looks a little bit nicer. We've got red, orange, yellow, green, blue, indigo, violet, and empty. Empty just means don't put any color there, although it sounds much more ominous than black. So let's go ahead and let's set up our variables. So we got red, orange, yellow, green, blue, indigo, violet, empty. And these are going to be filled with RGB colors. Still a lot of typing. You know, I'll be real with you. Still a lot of typing. But this is going to be a lot less typing than if we did all of this manually. And it's going to be a lot less to keep track of than if we did all this manually. So let's just say that this is the superior method. Mostly because it is. Oh, left arrow key still works. Amazing. I just keep thinking it's going to just die on me again. 0, 0. So 255, 0, 0. So if we go to our RGB Color Picker and we enter in 255, 0, 0, boom, in your face red. Crazy red explosion. 255, 127, and 0, presumably, is going to be our orange. Let's confirm that. Let's change the 0 into 127. Sure enough, that looks pretty dang orange to me. Cool. So that's our orange. Yellow, 255, 255, 0. Let's change this 127 into a 255. Boom. Yellow. Crazy, eye-burning yellow. At least we can confirm that works. How about green? 0, 255, 0. Pretty straightforward, right? Because it's an RGB. Whoops. 0. So if we did 0, 255, and 0, look at that green. It's quite the green. Blue is 0, 0, 255, as we all know, since RGB. Confirm, 0, 0, 255. Blue, quite blue. I is 75, 0, and 130. Now we're starting to get into some more sort of complex combinations of colors. Now, orange was a little bit strange too, but like 75, 0, and 130. This is the first time we're dealing with not a full bore, pipe all the way open color value. So let's try it. 75, 0, and 130. This is probably going to be a lot more pleasant than a lot of the colors we've been looking at. 75, 0, 130. Indigo. That is fairly indigo-like. Sure. Violet, 159, 0, 255. And here we're back up to the old familiar having a color all the way up to 255. 159, 0, and 255. Let's verify it over here, just like we've done a million times before. 159, 0, 255. That seems like a less dark color than indigo, which I've always been led to believe that violet is darker than indigo, but whatever. We've got that. And then we'll throw in some zeros for our empty. And that should be our set of values. We're going to have red, orange, yellow, green, blue, indigo, violet, and empty, which we verified with our RGB color picker over here. So now we've got a set of variables, which are our colors. Let's throw them into a big ol' array. And rather than typing out this array manually, because I'm not some sort of chump, I'm going to copy paste that as well. I'm also going to throw it into the thing. I'm sorry, Liam. Could I also paste the colors? Yeah, sure. Pasting colores. So now we've got the colors, and we've got the array that holds all of our colors. Now, a wild guess as to what exactly our image is going to be. How did you know? Just some kind of wizard? I'm a what? I'm just Harry. You're a wizard, Harry. Anyway, so how do you set rules for a while true statement? Excellent question. So this should still run basic Python. So you should still be able to say while true, but you got to capitalize the T in true. Boom. Ooh. And then loop code, yay, etc. So that should still work. You can just do the while true, and then whatever you want to be a part of the loop, you run inside of the. You show that it's inside of the loop by indenting it one level from that loop. Does that answer your question? Oh, so you can do like a if thing equals true, true, then you break, and that'll pull you out of the loop. How do you find the IP of the Pi? So it depends on the operating system you are running, for sure. Yeah, you could do IP address show if you're on the Pi. Yeah, if ifconfig will also work. If you're running on a computer on the network, you can do like an nmap or an IP config /all. Oh, now we're throwing in pipes and greps and stuff, trying to get all fancy. But yeah, no, totally. ifconfig pipe grep inet would work 100%. I'm actually going to copy this and paste it back and send to all so that people know what exactly I just said. A little bit of a yeah, 192.168 or 10.10. Depending if you have a really like fancy router, it might be a 10.10. Yeah. Well, I guess it doesn't have to be a fancy router. It can just be a strange router. But a lot of fancy routers also do 10.10. But 192.168 means an internal network. 10.10.10 also tends to mean an internal network. Really? Oh, well, there you go. You can do that too. Anyway, so now that I've got my, after we've spent an amount of time talking about using the console, or the terminal, I'm going to paste my little image variable here. And then I'm going to say sense.set pixels, plural, and then feed image into it. and hit run. And we got ourselves a rainbow. It's a rainbow. Look at it. I don't know why I'm talking like that, but it's a rainbow. So pretty neato, huh? Yay! Ah. So just to clarify what exactly happened here, yes, there is. I'm glad you asked. So if you're running Putty, and let's say you have, I don't know, Vim or Emacs open or something like that, highlighting stuff in Putty, actually, let me just go ahead and pull up Putty. So I'm going to connect a bandit over the wire. No, that's not what that is. No, that's not what it is. Oh, that's unfortunate. Bandit over the wire got a different thing. Anyway, if you click and drag with your mouse in Putty, you copy. If you right click, you paste. At least by, let's see here. If we go to behavior, translation selection. Yeah, so action and mouse buttons compromise, middle extends, and right pastes. By default in Putty, right should paste anything you have on the clipboard. So you can highlight something here and Control C, and then go over into Putty, and then right click and paste it onto wherever the terminal cursor is. Just make sure that you're like, if you're running Vim or something like that, you're on Insert. Yeah, but by the same token, the pie is powerful for what it is, but I think, I don't know. Honestly, I was just about to speculate, and it would have been nothing but that speculation. Yeah. That's part of the reason why I retracted my speculation. You'll, if you haven't noticed already, you guys have probably noticed that I like to start saying things and then realize that I'm wrong and I stop saying them. And that's just how I operate. That's just how I work. So don't be surprised if I start saying something that's wrong and then I stop saying it. It doesn't mean I still believe it's wrong. Usually it means that I realize that it's wrong. But anyway, it's 8:50. This leaves you guys with a nice little rainbow on your Sense hat. And you guys are primed and ready for setting orientation, which is going to be the next thing on Monday. But that's actually where we're going to leave off here. So I'm going to do the poll questions, and then I'm going to leave it open for question and answer time. After the poll questions are done, if you have any questions about anything, I'm here. Anything. I say that every time. I mean it. Doesn't have to be related to what we covered today. It can be related to something that you're working on. It can be related to life, whatever. If you have any questions about anything, I'm here. Otherwise, you're more than welcome to head out. Well, you could probably do a really janky way of detecting collision, and that is ask if it shares an X and a Y coordinate with the paddle, which would actually be the definition of collision detection. But, whatever. Let me go ahead and throw out the poll questions here, and then once you're done with those, if you have any questions, I'm here. Otherwise, you're more than welcome to head out and have a wonderful weekend.